Hello and welcome to ABB Basic Programming Tutorials. Today we're going to look at a basic motion line of code, and we're going to break it down and examine the different components in a line of code in a standard ABB motion. And we're going to talk about these and talk about the importance of each segment. So let's begin by starting a new program or a new routine. So I'm going to go to ABB main menu, and under there I select the program editor, because anything we're going to do with a program or a routine, we have to be in the editor to do it. So I select the editor, and apparently I'm in my main program here. So I'm going to go to routines, and I'm going to create a new routine. So I hit File and New Routine. And here are some things that we want to point out and we want to make sure of. Depending on what type of routine we're creating, in this case a procedure, a job that's basically a standard procedure that's going to do work. This is not a function, it's not a trap, and we'll cover the functions and traps in a later episode. They're completely different animals than a standard procedure. So we want to make sure we've got a procedure selected, and this requires no special parameters, and in this case we're keeping it in the main module. So we want to name our routine, and for this routine we're going to name it line. And we're just naming it line because we're going to be examining a few lines of code and breaking them down and looking at what each expression means in them. So the local declaration, error handler, backward handler, and undo handler options here, we're going to cover those also in another section. So we're going to leave them blank for right now, and we're just going to go with our routine called line. So we hit OK, and now we've got our routine. So we make sure our routine is highlighted, and we hit Show Routine. Now we're inside of it, and we see the empty line of code here, SMT, that stands for statement. And anywhere we see statement like this, we know that we have to use the add instruction function key at the bottom of the pendant. It's the only way we're going to get anything on the pendant here in this line of code, on the statement. So I choose add instruction, and the first menu that usually pops up, unless you've already been programming, is your common menu. And under common, I'm going to see a move absolute J, a move C, circular move, a move J, a joint move, and a move L, a linear move. The move absolute J is a joint move, but it doesn't match the standard point that a move J will, and what I mean by that is the way the point data is stored. For a move absolute J, the point data is stored by the resolver value for each individual axis. And the resolvers in ABB are very accurate 3-pole resolvers, which have basically 12,288 known positions and 360 degrees rotation of the motor shaft. So that's why they call it an absolute position. But we're going to be working with a standard move J here. And what the move J does, the way that it stores its point data, is it stores the location of the TCP, the tool center point, of the currently selected tool you have in your line of code relative from the work object that you have selected in your line of code. And this is going to be accurate for the type of the model of robot I'm working with here, which is a 2400 series. This is going to be accurate within 0.1 millimeters of each position, so it's still very accurate. So I'm going to add a move J in here, and as we see, the move J just pops in my line of code like this, and it came up with a point name as an asterisk. Now, if you're familiar with programming at ABB, you know that an asterisk is an acceptable point name. It's considered a generic point, which means I can't really recall this point without copying and pasting the line of code. But we get more in depth on point data, ROB targets as they're technically called, in another video that's in this series. So let's go ahead and add an option to this move J so that we can cover the whole line of code. I'm going to, any instruction that has optional arguments, if you double tap or tap the first word of that instruction, it takes you to an optional argument screen. And on this screen I can see that I'm traveling to point with my point values here at a speed of velocity of 1000 with a zone of 50 millimeters, and my active tool is tool 0. And tool 0 basically is the flange on axis 6. And that's very important to remember, because there's a big difference between tool 0 and, say, a weld gun. A weld gun would have a mass of at least 75 kilograms. Tool 0 has no mass. So if I were working with a weld gun here, then I would want to make sure to select the proper tool. because as the robot begins to execute the program, not only does it know what tool I have active, but it knows what mass to expect as it's traveling from point A to point B through the program. And if that mass is incorrect and the robot experiences an over torque or under torque due to an incorrect mass for my tool, then it's going to fault out. And you may have seen motion supervision or torque issues with robots faulting out in the middle of a program. Check your tool. The tool is one of the most important parts of programming. But let's add an optional argument in. When we go to the optional arguments here, we have a couple of options to choose from, actually quite a few. And the one we're going to focus on today is WOBJ, work object data. So I'm going to select the work object and I'm going to click Use. And it tells me a mod pause, a modify position, is required to use the newly created work object. Do you want to proceed? And I'm going to say yes. And the reason it tells me I must modify that position is because when I store this point, what the robot's really storing is the location of this TCP in space relative to this work object. So if I decided this was the wrong work object and I went back and chose, say, work object 1, whatever that may be, then my robot's going to try and bring this tool the same values X, Y, and Z from the new work object, and that'll be a totally different position in space. And we have more videos on that. We're going to be talking more in depth about the importance of the tool and the importance of the work object, and we'll also be covering all of the topics concerning those. So let's look at my line of code here and let's see what we got. We have a move J, a joint move, to this asterisk position. All right, well, let's give this asterisk position a name. Anytime I need to change part of my line of code that's already existing here, I have to double tap that line of code. Now, it's very important to remember, when I'm changing the point name, when I'm going to give it a new name, I want to make sure the robot is physically sitting in the position that I want it to be in. Because when I name this point, I'm reteaching the robot this point at the position it is currently sitting in. So, if I don't have the robot where I want it, and I go to run this code again, it's going to go somewhere I'm not expecting it to. So make sure the robot is in the exact position you want it in before you give the point a new name. So now I'm going to click New. And in this case, it gave me a default. It increments the points by 10, so it defaulted to 0.70. And it gives me the point up here. I know this point is safe to use. And what I mean by safe to use is this name is not already taken. So some things we want to check really quick when it comes to the point. Global. Now this depends on what you need. Do you want to make it global or local? Do I want this point to be accessible through the entire system, or do I want it to be localized to just a routine? That depends on your application. But the storage type is constant. We don't want our point data or our rob target data incrementing or changing, so we don't want variable or persistent. And we talk more about these in our variable videos. The task, well, I've only got one robot on this controller, so it's a pretty easy to decide that here. And the module, in this case, I only have my main module, so it's global. I'm going to keep it in the main. If I would have chose local here, then I would need to specify the routine that I'm going to localize it to. Dimensions, if I give it dimensions, it then becomes an array and not a point. And we'll talk about arrays in a later video. So P70 is global, constant. My robot, main module, looks good, so I hit OK. And now I'm making a move JP to P70. So I hit OK. Now we've got that part taken care of. This is how my robot's moving. Move J, a joint move, which means it goes from one point to the next as fast as it can. This is our speed move. It takes the easiest, most accessible route with the least amount of motion on each individual axis to get from where it's going to this point. The point name on your line of code, the P70 is the end point for this joint move here. Now moving next, I have V1000. The V simply stands for velocity. I can double tap velocity and I can go and change it to any one of my presets or create a new one. I'm going to speed it up a little bit to V2500. So I hit OK. And now I'm making a move J 2.70 at a velocity of 2500 millimeters per second. Next, Z50, zone. We get in depth on zones in another video, and it's called the approximation and the approximation range video. What a zone tells me is that my robot, once it's 50 millimeters away from P70, is going to veer off of the program path and return back to the program path once it is 50 millimeters away from P70 on the exit side. That might sound a little confusing. Think of it like this. I'm telling the robot to put a spear or a circle with a radius of 50 millimeters around P70. Once it enters that circle, it's allowed to leave the program path and head off towards the next point and return to the program path that is once again 50 millimeters away from P70. Alright, so now I've chosen my zone, I've chosen my velocity, I've chosen my point name, and the move type. Now if I want the robot to get exactly to that point, and let's say I do on this case, then I would have to choose a find move. And we'll talk about the benefits of a find move as opposed to a zone in the approximation videos. A find move also stops what we call the advanced run. So I'm making a move J 2.70 at a velocity of 2,500 millimeters a second. With a find move, that means my robot's actually going to slow down, stop at that point, and then head off towards the next point. My tool is 0 and my work object is 0. So I hit OK and I'll look at it again. So let's look at another example here in a Word document. Move J is your move type. P10 is your end point for this motion. The velocity is how fast you're going to get to this point. The zone is how close you're going to approach this point. This is your active tool, and this is your active work object. So it might look like a lot when we first look at a line of code, but as we see, it only says what it needs to say. The move type, where we're going, how fast we're going to get there, how close we're going to get to it, the tool I'm using, and the work object that I'm doing work on. Because the tool is the object the robot carries if it's a hold tool, a robot held tool, and the work object is a physical structure or something in the cell that we actually go to do work on. It could be a structure, it could be a fixture of some type, it could be another mechanical device. So the line of code as it breaks down is pretty simple. Move type or type of motion, point name or where we're going, velocity or how fast we're going to get there, zone or also known as the approximation range, how close we're going to approach this point, my active tool, and my active work object. So I hope that this video helps out a little bit understanding a line of code. We're going to be producing many more of these videos, program robots for a living. So we've got a lot of data that we'd like to get out and share with people. Please subscribe and like if you like the videos, and stay tuned for many more videos on robot programming. We have an approximation series. We're going to be covering constants. We're going to be covering persistence, task, everything. So just stay tuned, and we're going to break down robot programming from the simplest form all the way up to its most complex form. So thanks a lot for watching, and have a good evening.